Hey everyone, and welcome. Ever had that feeling where you know you're just one piece of information away from solving a puzzle? Well, today, we're going to crack the code on all sorts of everyday mysteries. And our master key? It's not some crazy high-tech gadget. It's algebra. Yep, that's right. It's the tool that turns real-world head-scratchers into problems we can actually solve. So let's jump right in.
You know that feeling, right? Staring at a problem, knowing you're missing some key info. It's so frustrating. But what if I told you there's a logical system for finding those missing pieces? Well, there is, and it's called algebra. And look, it's a powerful way to turn confusing situations into crystal clear equations. And it's probably way simpler than you remember from school.
And to prove it, let's put on our detective hats. Our first case file is all about two friends, Siri and Lakshmi. They go shopping, they buy some notebooks and pens, but here's the catch. Neither of them knows the price of a single item. All they have is their total bill. So, our mission, should we choose to accept it, is to find the true cost of those pens and notebooks.
All right, every good investigation starts with laying out the facts. So let's get our clues straight. We've got two separate shopping trips, and these two pieces of evidence are all we have to go on to crack this case.
So, here's what our investigation boils down to. Clue number 1. Siri bought 3 notebooks and 2 pens for 80 rupees. And clue number 2, Lakshmi grabbed 4 notebooks and 3 pens for 110 rupees. Right now, these are just words on a page. To really solve this thing, we need to translate them into the language of investigation.
And this, my friends, is where the magic really happens. We're going to translate these clues from plain English into the language of math, specifically algebra. This lets us work with all this information in a super precise and logical way. It's basically the secret code of all the great problem solvers.
So, the first step in any investigation. Identify your unknowns. In algebra, we call these variables. So let's say x is the unknown price of one notebook and y is the unknown price of one pen. From now on, x and y are our main suspects. Okay, let's translate that first clue. Siri bought 3 notebooks, so we'll call that 3x, and 2 pens, which becomes 2y. The total cost was 80 rupees. Put it all together, and our first equation is 3x plus 2y equals 80. And just like that, our first piece of evidence is officially in the case file. Now, if we apply that same logic to Lakshmi's purchase, we get our second clue. 4x plus 3y equals 110. And there you have it. The entire mystery boiled down to these 2 simple equations. This is what's called a pair of linear equations, and the cool thing is, we now have a few different ways to find the solution. You know, one of the coolest, most intuitive ways to solve this is to literally draw a map. I'm serious. Each of our equations can be drawn as a straight line on a graph, and this map, it's going to visually guide us straight to the answer. So, let's take our first equation. 3x plus 2y equals 80. When you plot that, it makes a straight line on our map. Now think of this line as every single possible price combination that could work for Siri's purchase. Like maybe the notebook was 20 rupees and the pen was 10. Or maybe the notebook was 10 and the pen was 25. Any point on this line is a potential solution, but we don't know which one is the right one yet. But now, let's add our second clue to the map. And bam, this is it. Do you see that? The 2 lines cross at exactly one point. This is the one and only price combination in the entire universe that works for both Siri's purchase and Lakshmi's purchase. That single intersection, that's our answer.
So what's this crucial point? The coordinates of that intersection are 20, 10. Now let's translate that back into real life. It means x is 20 and y is 10. The cost of a notebook is 20 rupees and the cost of a pen is 10 rupees. Case closed. It's that visual and it's that simple.
Okay, that was pretty clean. But we all know that in a real investigation, not every clue is helpful, right? So what happens when your evidence is, well, faulty? What if your clues actually contradict each other? Or maybe they're just telling you the same thing twice. Turns out, algebra can reveal that stuff too.
This slide really shows the 3 possible outcomes for any 2-clue investigation. On the left, that's our solved case. 2 lines crossing at one single point. One unique solution. But look at the graph on the right. In this scenario, the clues give us parallel lines. They run alongside each other forever, but never, ever cross. That means the clues are contradictory. There's no single price that could possibly make both statements true. So, this table is basically our complete detective's guide. First up, you've got intersecting lines.
Algebraically, we call this consistent and independent, and it means you get one single unique solution. Then you have parallel lines, which we call inconsistent. This means your clues contradict each other and sorry, but there's no solution. And finally, you might get something called coincident lines, where both clues are really just the same line in disguise. We call this consistent and dependent, and it means there are actually infinite solutions.
Now, look, graphs are awesome for visualizing the answer. They really are. But for pure precision, detectives need other tools in their toolkit. Algebraic methods let us crack the code directly from the equations themselves. No drawing required.
Our two main interrogation techniques are called substitution and elimination. Think of it this way. With substitution, you get one equation to confess what y is, and then you substitute that information into the other equation to find x. With elimination, you're a bit more direct. You cleverly manipulate the equations so that when you add or subtract them, one of the variables, say y, just completely vanishes, leaving you with a really simple problem to solve for x.
So, the substitution method is a pretty straightforward four-step process. First, we take one of our notebook equations and solve it for y. Step 2, we'd substitute that new expression for y into the other equation. This is the cool part because it leaves us with one equation that only has x in it, which is easy to solve. And finally, once we know x, the price of a notebook, we just plug it back in to find y. Simple as that.
The elimination method is just as slick. For our notebook problem, we could do something like multiply the first equation by 3 and the second one by 2. Why? Because that would make the y term 6y in both equations. Then, we just subtract one from the other and poof, the y terms are completely eliminated, letting us solve for x. It's a super efficient way to simplify the case.
Okay, so we've cracked the case of the notebooks and pens. Awesome. But let's be real, this isn't just some classroom puzzle. The exact same logic is used to make huge, high-stakes decisions in the real world every single day. So let's scale up our investigation.
See, every business on the planet tracks two key lines. Their cost line, that's how much they spend to make something, and their revenue line, which is how much they earn from selling it. The point where those two lines cross, that's the holy grail. It's called the break-even point. It tells them the exact number of sales they need to make just to not lose any money.
And by setting up a cost equation and a revenue equation and finding exactly where they intersect, a book publisher can calculate precisely how many books they need to sell to cover all their expenses, everything from printing to editing. In this example, that number is 25,600. That's not a guess, it's not a hope. It's a precise target, all calculated with a little bit of algebra.
So let's just quickly recap what we've uncovered here. We've seen how to translate real-world situations into the language of algebra. We've literally visualized solutions as the meeting point of two lines on a graph. And we've learned about the powerful algebraic tools that give us pinpoint-accurate answers. And the big takeaway? This is a skill that scales from a simple shopping trip all the way up to major business strategy.
So I'll leave you with this question. What mystery in your own life is just waiting to be solved with a pair of equations? Maybe it's planning a budget, or comparing two different phone plans, or figuring out a recipe. Think about the clues you have, because now you have the tools to translate them, map them out, and find the solution. Thanks for joining me.